And then it goes from x is equal to, say, 4 meters I hat to x equals 7 meters I hat minus y j hat. I think I've, different numbers, but I think I've hit all the important parts of that problem. And the question is, what is the speed of the object? All right, so first off, in this chapter, we're dealing with speed, so kinetic energy better be coming into it at some point. The speed, and I've given conservative, non-conservative forces, so it might seem a little daunting at first, but if you add them together, what's the total force acting on it? I need the whole thing. Yes. The j hat parts cancel out immediately. So my total force is 5 newtons I hat. Looking at the top one, I know that my total work is equal to the change in kinetic energy. Total work is equal to my total force times my displacement. Dot product is equal to K final minus K initial. And so now we get into sort of the essence of the dot product. So I have 5 newtons I hat dot 7 meters I hat minus y j hat is equal to 1/2 mv final squared minus 1/2 mv initial squared. I gave you the mass of the object, so we should be able to find that. We're trying to find this, and I gave you enough information to figure out what the initial speed is. Whenever I have something squared like that, so vi squared, well, that's just vi dot vi. Did I put a, oh, I didn't give an initial velocity there. So let's make one up. Uh, 4 meters per second I hat plus 2 meters per second j hat. So when you're doing a dot product, what do dot products care about when multiplying? For those who are less familiar with dot products, there are, since it's a math thing, I think at the very beginning of, might be stuck in chapter 1, but it's basically, there's some videos on dot products and cross products, the other one. Dot products care about parts that are parallel. So if I have 4 I hat plus 2 j hat dot 4 I hat plus 2 j hat, which of the parts are parallel?
The 4 I hats.
Yeah, those are parallel, and the other ones are parallel. I multiply the parallel parts. 16 plus 4. 1. That's vi squared. You could also look at it from this point of view. Any vector doing a dot product with itself, what I care about is the parallel. Actually, let's do a non-parallel to start with. If I have some vector A here and some vector B here with some angle theta in between, the dot product between A and B, well, I care about which part of this vector is parallel to that one. And now for some stunning, absolutely stunning visual effects. B can be broken up into two parts here. There's part that is going the same direction as A and part that's perpendicular to it. Well, dot product looks at the perpendicular piece and says, I don't care. All it cares about is this segment right there to multiply times A. And that is adjacent to that angle. And so this becomes whatever the magnitude of B is times the cosine of theta. So the dot product is just magnitude of A times the magnitude of B times the cosine of the angle between them. So if I take a vector and multiply it by itself with a dot product, what's the angle between these two vectors?
0.
And what is the cosine of 0?
1.
So this becomes A times A, or A squared. Now that's for polar form. If you're in rectangular form, you're just multiplying the i's together, the I parts together, you multiply the j parts together, k parts if you got them, and then add the scalars. This is a scalar product. So multiply the I parts together, 35. It has no j part, so that goes away. So again, 35 is equal to 1/2 times whatever the mass is, so we'll just make the mass, what number have I not used yet? I haven't used 6, so the mass is 6 kilograms. 1/2 times 6 times my final speed squared, minus 1/2 times 6 times my initial speed squared, which is 20. One equation, one unknown.
For the 5 newtons I hat times 7 meters I hat, why wouldn't you do 5 newtons I hat times 3 meters I hat? Because that was your displacement. Like if you went from 4 meters to 7.
Oh, you are absolutely right. That should be a 3 there. Change in position, final minus initial. Yes, sorry about that. So 15. Questions? I see at least one furrowed brow. All right, any other questions on chapter 7?
Actually, do you have a question about this?
Yeah.
When you were given your initial velocity, could you just do a squared plus b squared equals c squared to find the magnitude of that?
Yeah,
Is
so
that
in essence,
okay?
doing it that way, so let me pick numbers that I can do in my head better. So if I had 4 meters per second I hat, so we'll just be plus 3 meters per second j hat. So that's 4 this way, that's 3 this way. Then my resultant is a vector like that at some angle. And so that's a 3, 4, 5 triangle. So this is also 5 meters per second at an angle of around 37 degrees. 36.8 something.
And you would plug that 5 where you plugged in that 20?
I'd plug in 25 over there.
Oh.
So if I do V dot V, well, the angle between them is 0, so I'm just multiplying the magnitudes. So V squared over here would be 25.
Got it,
That
okay.
with the velocity.
Okay, makes sense, thank
Yep.
you.
Other questions? All right, let's jump to momentum. Anybody need to stretch legs, or we good to just keep plowing through? All right, I got a thumbs up and we're good, so, or I'm good. Are you speaking for yourself or everyone?
Everybody else.
Okay, excellent.